have a next presentation focusing on digitalization of industries. We are talking digital transformation, so that's the core part. And to deliver this presentation, it's my pleasure to welcome Sudhir Dembi from Aveva. Can I request Sudhir to come on stage?
Good evening, everyone. So I'm Sudhir. I represent Schneider Electric, as well as and we have a department called Software-Defined Automation, which works at agnostic software and hardware platforms and the solutions what we are presenting. So I will be today talking about digitalization, and under which a lot of changes what we are bringing in, the more efficiencies out there. When we talked about data management, we talk about AI, how we are making it much more open, how we are trying to utilize the generative ones into the system, and use off-the-shelf technologies, what we are enabling. We're not going to be dependent on the vendors. You can have open systems out there, what we want to bring to the table. So if you see what we have, the evolutions what we had, I think we covered certain things out there. We have been at the forefront of the evolutions. What we see, we started the green part, where the machines were not there, and today we are trying to be in the fifth revolution, fourth beyond. It will be more about machines talking to each other, being coexistence of the machines, robots, and be in balance with the ecology, I would say, or that's we want to be there. So we want to do that, and how we want to do that is something which has to be gone beyond what we did at Industry 3.0, where we did the semicon revolution happen. When my friend already told you, we were the innovators on that. We bought the first PLC into the market. Foxborough had its first DCS. Connectivity on the intercommunication between different controls was done. We were the first ones. And we were the first ones also on the graphical visualization tools like Wonderware, which is the first one out there, and then we built up something called, everybody knows, the Pi Data Historian, which is also one of the best ones. What we say, gold standard in the industry today as a historian piece on what you built up, a lot of additional things, what we can bring, much more productivity can be brought into picture at your factory floor. So that is what we are bringing in. We want to be forefront of this revolution. We want to remove certain blocks which are there today into the controls of today and bring to the technology which is available today off the shelf, where the innovation happens and you are able to utilize that innovation at your factory floor or process solutions. So what we have, okay. So in order to fulfill this whole thing, we are very well knowing our architecture. It is a generalistic architecture. I won't like to say it's an EcoStruxure architecture in a way, but it is the typical architecture what we have in the factories. We have connected systems, what we talk about the connected layers, where you have the walls and breakers, you have all the things together out there, push buttons, all those things, servo drives, AC drives, all those things come here. And the edge layer is a control edge. And then you have the software layer which picks up the data, which is the data analytics. You want to have MES on top of it. You want to have AI-driven solutions, or you want to have advanced process control. All this has other things. Well, this is what the Aveva layer does. And on top of it is our design engineering tools, which are other than the industrial one, where we do under Aveva, the PNIDs and all, we do the piping and all. But we have something for the digital buildings, where we have RIB, ETAP for the power, and LP, and plan on the other product lines what we have. So we cover all the things together in this whole jigsaw puzzle, what we need an industry to be efficient, or a building to be as per the latest standards, or it will be sustainable businesses, what the designs are for. But what we see is, we still have at the edge layer a bit of challenge where you are, lot many people have the old technologies which are not coherent with the connecting to the latest AI-driven solutions out there. And you have a big vendor lock out there. There was a bigger challenge out there, the vendor lock. If you have X brand, you have to continue with the same brand. So what we did was something different out there. So we talked about a system which is open, which is software defined. So what we wanted to bring was to unshackle this closed door combination of hardware plus software. If you have an X brand, you have to go with the same software to program it, to do your algos, have it talking to the controller, want to delink that. So that's what we came out with, a software-defined automation. So we thought, let us unshackle it. So we went with the open platform. So what does it mean to have a software-defined automation out there? It is an ecosystem where we're talking about, when we talk about ecosystem, is for your whole factory what we're talking about. We're talking about right after the design, having that integrated tools out there on it. We are talking about virtualization of the controls out there. Virtualization controls means we are making for the standard controls what we use today. We are using normally controls which are on the rack-based system, whether it's DCS platform or the control platform. We are opening up, going to the next level. Now, why don't we use standard servers out there? Standard off-the-shelf blocks out there, use them. Put the function, put the codes in there. Make the algos run in there. Today, none of the plants can work without a control room. That days are gone when you had a push button as a backend system. Today, all the thing is SCADA controlled or HMI controlled, where you have a control room, you are driving the things. And why I cannot move the control to the server layer itself? That's one of the ideas what we are talking about. We are not going for the we are not saying no to the traditional ones. We are giving you the option of moving towards the virtualization controls. What it gives you also is lot much more flexibility. You can run your system independent of those vendors, and you will have much more data out there coming from the field. Today, a lot of people are talking about Foundation Field Bus. We are also talking about Ethernet IP, Profinet, and other protocols, where you can have all these sensorization done directly into the control layer, into the not control layer, into the edge control, and you do all the analysis. Also, it is open connectivity in the backend with the analytical layer. You can run your AI engine in parallel with it, do the corrections on the fly, give a really, I would say, what we say, really compliant to Industry 5.0 principle what we want to go with. So these all things are done under a new platform what we talked about as an automation expert. And this is a part of our flagship offering what we have today, which is under evolution, I would say. But this is a part which has been opened out there to all the vendors. We have done certain use cases already, certain successful cases out there, what we did in the plastic industry in Italy out there, where we have a coexistence of different hardwares together under the single software layer. We're talking about engineering software layer. We are not talking about the software layer which is different engineering software layer. Suppose I have got X brand, I have to go the same one. A Y brand has a different one, and they talk on the same platform. We're not talking about that. We're talking about single engineering tool, single HMI tool out there doing that. So that's what we are doing. So it gives you unlimited possibilities, flexibilities as an end user. So you can tomorrow you can use any other vendor out there which is compliant to these standards under the universalautomation.org. So you can easily transfer the programs one to another, keep the system running under this platform. So, oh shit, sorry, I'm pressing it fast, so it's creating a bit of fuss. Okay, so what we have done so far, so we have two different platforms available. One is standard compatible hardware platforms that we have for this product lines. And then we have virtualization control as well available, where you see on the left-hand side, what you see is Linux or Windows-based OS, where you can run the algos, which will be in performance in line with the hardware platform, what you're seeing on the right. So you can have the flexibility of this platform. You can do what you want to choose. If you've got a higher-end memories to be required, you can use traditional memories, or you can use one more controller out there to run that. It could be off-the-shelf controller to the job. So this is what we do on software piece. So you have both the things possible. You want to do whatever you have, your enormous flexibility out here, and you can have a really reduced total cost of ownership, what we want to say. You're not dependent on our hardware. You're going to buy the same hardware out there. If the one system is running, you can use any other hardware which is compatible with UIO. So what do we do on data continuum out there? So that is another piece where we found there is a loss of engineering hours. So what we did is we integrated all of them in a one go into this digital continuity out there. So once we have a design done, we have done a PNID done, we can just transfer it as it is. It will put the algos out there, run up the program. You have to only check it up through the generative AI and get the things done. So that is what we do on the software-defined automation, give you a next level of openness out there, next level of efficiency on the engineering side. This is the control layer, what we are bringing in. On the digitalization part, so we were talking about automating the processes and streamlining the processes. That's another piece out there what we want to do under the digitalization. So if you see, our solutions are across the board, right up from the engineering tools, from the energy and automation combined together. We offer all the product lines out there which can make your plant energy efficient. We have a design, build, and operate and maintain function from Aviva where we do the E3D drawings, we do the HMI graphical and the advanced process and advanced analytics on it. And another part, what we want to bring the next level of efficiency is having a unified command control centers for you, where you can see all the things at one place. You will have the right information for the right people at the right time, triggered out there and do the corrective actions. And today what we have is not a transparency that, like what we would like to have at the board level, but here we provide that. You have each and every asset at your click of your hand and you can see what is happening and running it around. Overall, these all actions, what it gives you is a productivity improvement of 20%, what we see. We see energy saving when we see the data coming out. You can do up to 15% with the generalized, what we're talking about. And 30% increase workforce efficiency out there increased, and reduction in maintenance cost of 30%. That has been basically what we have done so far. It can vary from site to site. If the site is well maintained, it could be a different one, what we have. But thing is, traditionally, when we use these technologies, there's the reductions, what we have seen happening out there at the factory floor. So, what we have today is learning, we are doing translating, we are connecting all the data points together, and tomorrow what we want to achieve is unplanned downtime reduction of 0%. We want to have accidents reduced to 0. We want a greenhouse gas emissions to 0, and innovation and empowerment at every level. So that's what we want to achieve for tomorrow with our platforms out there, and we are proceeding in that direction with our technologies in hand. So by using the technologies of AI, we are able to do this. We will be able to do this to reduce that, give early indications to the people out there, to the operators, what he has to do. We are also working on something like a perfect batch solutions where you can put AI engines on top of it and give you the indications early on that you are deviating from the paths and do the corrections out there to give a consistent perfect batch scenario out there and do the corrections on the fly. So that's what we are looking at. And in the end, the future will be, looks like what we have, a few places we have been talking about dark factories, we have been talking about autonomous factories running, everything run on their own, where there are few cases out there. That's what we are trying to achieve out there, which is possible. And In certain cases, it will be possible. In certain cases, you still will have people, but majority of things will move towards autonomous operations where the minimum things will be required for the operators to do, but they will be required for the making the operations run. But that's what we want to achieve with the technologies what we have in hand. So overall, we operate and produce together out there, work it in a better way to make it an efficient enterprise of tomorrow. So that's all. That's what we have overall. This is a typical scenario what we had put in our digital twin operations for a refinery. What you see out here, and what you see here is unified operation and command control center, where you are seeing all the command control system, where it's from the enterprise right up from the oil and gas exploration till the last mile retail outlet, all at one go, where you person can look at any changes which are happening on the fly, do the corrections out there, indicate the people at the ground, the corrections to be done, there's the challenges what you have, and address it at the right time in the right earnest, I would say. That's all I have from my side. Thank you.
Thank you, Sudhir, for showing us a glimpse of the future. Zero downtime, zero greenhouse gas emissions, zero accidents, and even more, I'd say, futuristic when we are talking about autonomous operations in factories.